Okay, so this one leaves us with kind of an ugly looking problem, but it's not as bad as you would think. We're going to start out by just taking a slice out of here and looking at a common truss. So a common truss is going to look like that of the span of 32 feet, slope of 612. First thing we're going to find is the height of that. To find the height, we need to know the run, which is 16, half the span, half 32. 6 over 12 equals h over 16, gives us that this height is 8 feet. Now I'm going to use that to fill in right here the length of the common rafter. How do I find the length of the common rafter? Square root of 16 squared plus 8 squared. $17.89, you got it. So this here is 17.89 feet. Now, if we knew this distance here, we would be able to find theta real easily. How do we know that distance? Well, we're going to come out here, and we're going to look at that setback and that mono that sits out there on the hip. How do we find the setback of the hip? Well, we know the height is 8 feet, and we know that the slope is now 10/12 on the hip. So 10 over 12 equals 8 over whatever that setback is. So 12 times 8 is 96, divided by 10 is 9.6 feet. This setback here is 9.6 feet. At this point, we can find theta. To find theta, I am going to first find this angle here, which will be the inverse tangent of 9.6 over 17.89. Everybody see where the 9.6 and the 17.89 come from. So this is 28.22 degrees, which means that theta must be 118.22 degrees. Where did I get that from? This piece here must be a right angle. Must be 90 degrees. Add that to the 28. What's that? That's too far off. That's too far off. 116? Did you have the 17.89?
No, I think we figured it first. The setback is different.
Okay, so the 9.6 is what's off. If you had the 17.89, that's a start. Most people screw up the 9.6. They forget the 1012. Yep. Okay, so now then we need to look at this one over here. We know this is 16 feet. We need to find this length. So I'm going to come back down here. This is 9.6 feet. That is going to be the square root of 9.6 squared plus 8 squared. Gives us 12.50 square, or 12.50 is that length. So which means that alpha is going to be found as the inverse tangent of 16 over 12.5. Then, of course, times 2, because that's just going to be half the angle here, right? Alpha is the whole thing. What we're finding is just this half. So second tangent, 16 divided by 12.5. Gives us 52 times 2 is 104. That is 104. So alpha is 104 degrees. 16 over 12.5. L is going to be really easy. It's 48 minus 9.6 and minus another 9.6, which is 28.8, I believe. Correct? Feet? Just the whole length minus the 2 setbacks. 28.8 is what we get. Now for our area, we really have everything we need. We have 2 triangles here. I'm going to call that area A here. The triangles are both 32 by 12.5 divided by 2, and then of course times 2, because there's two triangles. So that ends up with an area of 400 square feet for the two triangles. Area B will be the trapezoids. That's going to be 48 plus 28.8 divided by 2 times the height of 17.89, and then of course times 2 because there's two of those. So we get for the two of them 1373.95. 48 plus 28.8 divided by 2. You're averaging the two bases of the trapezoid. So to that we're going to add our 400. We get 1773.95. What do you guys think? This one is really not as tough as it looks. This one is you just got to see the triangles and know that you can transfer the height from the main slope to the hip slope.
Well, it takes a while.
It takes some time, but it's not like horrible. Not like pull your teeth type bad. Yeah, Grant.
Well,
You're confused, Grant. What's up?
no. Why didn't you get all back there?
Okay, so I'm going to have you set your quiz aside for now, and we're going to hit on our new stuff for today. We're going to take a little bit of time to review arcs and arches. Pretend that's a symmetrical arc there. And here's the information I'm going to give you. I want to know, I'm going to tell you that this is a 48-inch wide arc, and that it sticks up here 8 inches. I want to find its area. With what we now know, we can do all of that. So I'm going to expand this into a full circle. Yes, it's a little bit squashed, but oh well. You get the picture. And we're going to do this. We're going to cut it here. We know that this dimension here is how much? 8 inches. Now we're assuming this is going to cut it at a right angle, and this is going to go through the center of a circle. So that makes this dimension how much? 24 and 24, correct? So this dimension that we're going to be looking for is going to be called x. And we know that when you have two chords that intersect in a circle, the product of the two lengths is a constant. So 8 times x has to equal 24 times 24. So in other words, x equals 24 times 24 divided by 8, otherwise known as 72 inches. So now what does that tell us about the circle? What's the diameter of that circle? Is it 72? No, it's 80. Where did 80 come from? 72 plus 8. So I have a radius of 40, just half of that diameter. Now, before we can do anything, we need to know something about this triangle. We need to know the central angle so we can find the area of the sector. Well, I can find the area of, or the half that Drew. Gentlemen, quiet. We can find this angle here because we know that this is 24 and we know that this is 40. We have the opposite side and the hypotenuse, which is the sine. So this is going to be the inverse sine of 24 over 40. So second sine 24 divided by 40 is 36.86, but that's not the angle we're looking for. We're looking for the whole thing, so we'll double that times 2, 73.74 degrees. So what we have here is a central angle that is 73.74 33.74 degrees. Questions so far?
Slow down a little bit.
The inverse sine is to find this angle here out of this triangle. Once we have that angle, we doubled it to get the whole angle. So our next step is going to be to find the area of the sector. Area of the sector is the area of the whole circle. So that'll be pi times the radius, which is 40 squared. And then that's multiplied by that central angle, 73.74 over 360. So pi times 40 squared times 73.74 divided by 360. 1029.60. So the whole sector has an area of 1029.60. The triangle has an area of 48 times, because this whole distance is 48. What's this length here? I say it's 32. How did I get 32 there? For the height of the triangle. This is 8 up here, and the radius, the whole radius from the center out is 40. So it's just 40 minus 8 to give us that height here of 32 inches. So 48 times 32 divided by 2 because it is a triangle. That gives us 768 square inches for the triangle. So that segment that was out there is the difference between those. So we're going to subtract. Get 261.60 square inches. That's just the difference between the 1029, which is the whole sector, and the 768, which is the triangle that's missing. We've done that one before a few times. We just do it now with the trig. Makes it a lot easier now that we know the trig. So our next step, what if we're given different information? What if I tell you that this has a width of 60 inches? Oops, sorry. Never mind. This has a width of X inches, a height of 10 inches, a radius of 50 inches. Can you find X? Maybe. What are the chances that the radius and the offset would add up to the width? Well, if we do this, right, we're going to find this dimension here that goes all the way down. We'll call that Y. We know this is 10 here, right? I'm going to call this piece A and A. Why am I doing that? A, yeah, 2A equals X. I'm just cutting X in half. So I know that 10 times Y equals A squared. 10 times Y equals A times A. But I also know 10 plus y equals how much? 100. Where did I get 100 from? I got a radius of 50, which means that's a diameter of 100. And 10 plus y equals the diameter of the circle. Remember, y comes all the way down here, all the way down to the other side, not just to the center. So that tells us right there that y must be how much? Y equals 90. So that means 10 times y equals a squared is going to become 10 times 90 equals a squared. What's 10 times 90? 900. And from there, what do? Square root. So a equals 30. So is that what we're looking for?
Yes.
No, it's not. We have 30 plus 30 equals 60. X does equal 60. Not so bad, eh?
Well, that one wasn't.
Okay. In that case, I leave you with this problem for the first hour. No, this is not half a circle. We have a shed that has a 12-foot high wall, has a span. Redraw this a little bit. It has a span across here of 24 feet. Has an overall height of 18 feet. And a length of 60 feet. So the 18 feet is the overall height. I want you to find the volume of the shed and the surface area of the shed. I'm going to give you the last 6 minutes plus any extra time you come up with during your break to work on that, and we'll discuss this to start our second hour. Okay, I promise you we'd come back to this one, so let's take a peek at it. So we're going to start out by assuming that this is a full circle, get some information off of that. We know that if I cut this down through here, this gets cut in half at 12 and 12, half of the 24. Do we know this length here? Anybody? It is 6. Very good. Where did we get that from? The 12 and from the 18. You got it. Now we're going to find this distance here, which is x. That's what we're going to find. So we know that 12 times 12, or actually 6 times x we're going to start out with, has to equal 12 times 12. So 12 times 12 divided by 6 is 24 feet. X is 24 feet, which means the diameter of our circle is how much? 30 feet, which means our radius is 15 feet. Now that we have a radius, we know that's 12. Do we know this length here? It's 9 feet. How do I know that? Because it's 15 feet is the radius all the way from here to here. I subtracted out the 6, so this piece has to be 9. So I have this triangle here. That is 9, 12, and 15. So our next step. We're going to find the area of this segment up here. To find the area of that segment, we must find the area of the whole sector, which means we need to know the angle of the sector. So we're going to find this angle first. That angle will be the inverse tangent. What would be the opposite side there? From this angle, the opposite side is 12. And the adjacent side here is the 9. I could have also used an inverse sine of 12 over 15 would give me the same angle. $53.13. Now I'm going to multiply that times 2 because that's just half of the angle. That's just one triangle. I wanted the whole thing. So times 2. This is 106.26 degrees. Now I said we could have also done an inverse tangent and used opposite over hypotenuse, or an inverse sine, I should say. Do an inverse sine, it would have been 12 over 15. Would that give us the same thing? It better. And it does. So we know our central angle here is 106.26 degrees, which allows us to find the area of the sector. Which will be pi times 15 squared times 106.26 degrees over 360 degrees. So pi times 15 squared times 106.26 divided by 360. Giving us 208.64 square feet. Now that's the area of the whole sector. What do we need to subtract from that? We need to subtract the area of the triangle. The triangle that was 24 feet across here has a base of 24. We found the height of 9. So 24 times 9 divided by 2 is 108 square feet. So the area of our segment will be the difference between those. We take 208.64 minus 108 gives us 100.64 square feet.
24 by 9?
24 all the way across here by 9 feet. So now we can start looking at pieces here. So what I'm going to do is this. We have piece 1 here is this segment of a circle. We found that to be 100 point what? 64, right? Square feet. Piece 2 is this rectangle down here. How big is it? 12 by 24 is 288 square feet. So the area of the whole end of this thing is how much? $388.64 square feet. To find our volume, we're just going to take that 388.64 square feet, which is the area of the end, times the length of 60. A lot of it, yes. Just a little bit different. So it's 23,318.4. Cubic feet is our volume. Questions at that point? Now for surface area, we have the area of this end here, the 38.64. I'm going to multiply that times 2 because there's also another end down there. Which gives us 777.28. Next, I have this wall here, which is 12 feet tall by 60 feet long. Times 2 because there are 2 of them. There's one on the other side. Which is 1,440 square feet. Any questions so far? So all we have left is this curved part of the roof. To find that, we need to know the length of this arc here. To find the length of that arc, we find the circumference of the whole circle, which will be pi times 30, pi times diameter, or it would be 2 times pi times 15, 2 pi r, times our angle of 106.26 is our central angle again, over 360. Which gives us 27.82 feet. Anybody have any questions on where I got that length? So what's that telling me? That's telling me that from this arc here is 27 point, what was it? 82 feet. So the area of that piece up there is 27.82 times 60 feet of length. Or 1669.2. So that means that our total surface area, found by adding up all of these, is 3,886.48 square feet. How many of you think you could do that on a test or quiz all by yourself? Not a chance. The bottom, no. The ground is on the ground. We're just figuring out the wall. I should be careful when I say total surface area. Let's say the surface area needs to be sheeted with steel. How's that? I did say that poorly. You're right. Yes, sir.
Back down to show where you got that last surface area.
This here, you mean? The roof part, the top?
Yeah.
I found the length of this arc. The length of that arc is pi times diameter. That's the circumference of the whole circle. Then you take the circumference of the whole circle times your angle over 360. Then once you have the length of that arc, it's just a length times another distance to get the area. That arc times the 60 feet up the roof to get the area of the roof. Well, let's take another example for us to play with. That's all that matters. No, it's not your hat. Little blocky to be your hat. By the, I'll tell you when I give you the worksheet. Anyway, let's take a look at this. Let's say that this is 40 feet across. This is 40 feet high. And this here sticks out an additional 16 feet. This is 8 feet tall, and it is a 412 slope. I want to find the area of this. Just the area for now. Well, it's not as bad as it sounds, but it is kind of bad. You're tempted to say, well, first of all, oh, I screwed up here, I'm sorry. That's not 40, this is 20. Makes life a whole lot easier if that's 20, doesn't it? It's actually a half circle. Yes, that's what I was shooting for. This is actually a half circle. So it's really tempting to find the area of that half circle, since we could just do pi times 20 squared and divide by 2, and we have the area, wouldn't we? But the problem is, that would leave us with finding this area over here by itself. And guess what? It's impossible to find that area out there by itself. So the way we have to break this up is right here. We're going to cut it like that. That's a radius. So that is still 20 feet. Now I'm going to ask you a very important question here. Is this a right angle out here? Right there. No, it's not. It would only be a right angle if this line here were a tangent, and it's not. But since it's not tangent, we actually know that this is an obtuse angle. How do we know it's obtuse? Because if it were acute, it would actually cut through the circle like this, wouldn't it? So since it stays outside the circle, it's either got to be a right angle, it has to be tangent, or it has to be obtuse. So we know that. Does that make sense? That has to be obtuse? That's a key part here. Knowing that angle is obtuse is going to be key in just a few minutes. So now then we can do this. We're going to cut that across there because we know this has to be a right angle. We have a horizontal and vertical dimensions must form right angles with each other. Do I know that distance there? 36. Good. Half of the 40 is 20. Plus the 16 makes 36. Well, I already know then everything I need to know about that triangle right there. First of all, can I find this angle here? Yeah, that angle is going to be the inverse tangent of, what's the opposite side? 8, adjacent side? 36. $15.53 degrees. 12.53 degrees. I don't know where I got the 15. 12.53 degrees. So this angle is 12.53 degrees. What that means is this angle up here is 77.47 degrees. How did I get that? Subtract from 180. Very good. 180 minus 90 is 90. Minus 12.53 is 77.47. Do I know this length here? We can find it rather quickly by doing, you got square root of 36 squared plus 8 squared, 36.88 feet. Now then at that point we look at the other triangle and it looks like the only piece of information we have is the 20 and the 36.88. We need 3 pieces of information though to do anything with a triangle. So this is where we're going to have to manufacture a little bit of information here. If this here We're a triangle there. Do I know anything about it? Yeah, I know it's a 412 slope, don't I? Which means this angle here has to be the inverse tangent of 4 over 12. Which gives us 18.43 usually. 18.43, there it is. How does that help us? But what do I know about this angle here? It's a right angle, right? Horizontal and vertical dimensions. What I found is I found the angle here from the horizontal for this slope surface. And I can find that because the slope factor always goes off the horizontal. So I'm basically finding that heel angle from my slope, and I'm adding it to 90 degrees because this is a square corner. So that's telling me is that this complete angle from here to here is 90 plus 18.43 or 108.43 degrees. So you might be wondering, okay, how does that help me? Well, because I know that this piece here is 77.47, I can now find this angle by taking 108.43 minus 77.47. That is 30.96 degrees. Get some of this crap out of here so I can read. There. Now that I know that that's 30.96, we have a law of sines situation here, don't we? I'll call this side over here little a. I'm going to call this side over here big A, or this angle big A. I'll call this angle here big C. I know that 20 over the sine of 30.96. Actually, I'll do this over here. Just to give myself smarter. Is going to equal, let's go for angle C up here next. 36 that's the only one I can because the 36.8 is the only information I have, right? Other than the 20 and the 30.96. So I've got to use the 36.88, and that'll be over the sine of angle C. Now remember a little bit earlier, what did we say about angle C? It has to be what? Obtuse. And what does that mean that's going to happen here in this process? When we get the angle, that's it. We've got to do the supplement of it. So we're going to cross multiply and divide. So sine of 30.96 times 36.88 divided by 20 gives us that this sine is 0.9486. I'm going to do an inverse sine, so second sine of that answer is 71.55 degrees, but we have to do 180 minus that. So that angle is 108.45 degrees. Everybody catch that? 108.45 degrees. Any questions there? Which means this angle here must be what? (40.59 degrees). How do you get that? Very good question. 71.55. Sorry, 180. Let's just do this literally. 180 minus 108.45 minus 30.96. 40.59. Now that I have that, I can find the length of A here. If I were doing a roof area, I would need to know the length of A. In this case, I'm not, so I don't need to find the length of A at this point. Do I know this angle here? Kind of, don't I? Is that 120.88? Is that what that comes out to be? Somebody double check me. $126.88. I'm actually pretty sure of it. Perfect. So now I'm ready to find the areas. Area 1 here is pretty simple. How do I find it? Area 1 is a triangle that is 8 by 36. Divide that by 2. What's that? It's just 36 here and 8 there. It's just a regular right triangle. Piece 2 here is another triangle, but it is not a right triangle. So I'm going to use the 36.88 times the 20 times the sine of the angle in between them, which is the 40.59 over 2. $239.96 square feet there. And then third, we have this area here, which is going to be the area of the whole circle. So pi times 20 squared times 126.88 over 360. For 42.89. So then for our final answer, take the 144 plus 239. How about we clear that out? 144 plus 239.96 plus 442.89, which gives us a total of 826.85 square feet. What do you guys think? Should I just give you a worksheet and turn you loose?
Can you go over that homework, just run through the answers?
Yeah, let's go back through that.
On the right track.
Let's see. Which worksheet? 423A or B?
424?
Okay, we did A and B, didn't we, already?
Yeah.
So we're going to do 424 next, okay? Let's do worksheet 424. So on worksheet 424, number 1. Come on. Alpha, 22.62 degrees. Beta, 36.87 degrees. Those are just your heel angles. Right? Theta is found by subtracting from 180 is 120.51 degrees. And your roof area, $1,946.72 square feet. Anybody have those all right? First 3. Number 2. Number 2, we have the same slopes. That makes this one a lot easier. Alpha is 81.64 degrees. Theta is 130.82 degrees. D, which is your ridge length, is 20 feet. And your area is 1,736.6 square feet.
I got the first one, and I got D, and I got the roof area.
But this one didn't come out? What'd you get for theta?
149.75.
Because what you're doing is when you're looking at the side of the roof, you have this, right? This is your common rafter length, and this is your setback. So on this one, your setback ends up being 15 feet. Your common rafter length, we've got 30 here, so this is 15 on a 712. Which gives you 8.75 feet here. So your common rafter length is the square root of 8.75 squared plus 15 squared. So your common rafter length of 17.37. So this angle here is the inverse tangent of 15 over 17.37. $40.81 degrees, right? And this is a 90-degree angle, so I'm just adding 90 to it. Gives me, I get 130.81 instead of 82 this time around. But does that make sense now? Number 3, alpha, 88.83 degrees. Theta, 118.98 degrees. Now this one, the setback is not, the slopes are not the same, so the setback is weird, giving you a ridge length of 28.62 feet. And an area of 1,740.89 square feet. Then finally, the fun one, number 4, everybody's favorite. The roof area is 371 square feet, or 3.71 square of shingles. Remember, square is always 100 square feet, so divide by 100. Cool. Well, I will give you guys, I'm going to give you guys a new worksheet. I will let you guys have the last 17 minutes to work on the new worksheet once I hand it out here.